So, like Chris mentioned, I'm going to be showing you what building in TypeScript looks like. This isn't going to be a full like zero to hero course on TypeScript. Really, the goal is kind of just to give you what the vibe of building on Algorand looks like. And then afterwards, we'll give you a challenge where you can kind of get your hands dirty and learn a little bit more about how TypeScript development actually works. So, what I'm going to do is I'm going to start off in a blank terminal and just show you how you can get started building with AlgoKit and TypeScript. And then I'll go over to a completed project that has a TypeScript contract and a front end and walk you through how we write our contract and then how we integrate that in our actual front end. So, but first, if you're a new developer on Algorand, the first thing you want to do is install AlgoKit. Now, if you already have Python installed, then this is pretty easy for you. You just need to run a pipex install AlgoKit. And by the way, if anyone in the back, if it's too small for anyone in the back, just let me know and I can bump it even bigger. But to install AlgoKit, you just do a pipex install AlgoKit. And we also distribute installation scripts on Brew as well. So if you're on Mac OS and want to install AlgoKit through Brew, you can. And also on Windows, we support Chocolatey as a package manager. So you just run that and it'll install it. I've already installed AlgoKit, and I didn't want to risk like the Wi-Fi going out in the middle of my presentation. So I'm not going to be showing you the actual install step, but it takes like a couple minutes to install at most. So once you have AlgoKit installed, if you run AlgoKit, it'll show you all the different commands. We don't have time to go through all these different commands individually. So what I'm going to really be focusing on is the commands you're going to be running as a first-time developer on Algorand. So the first thing we want to do is we want to init a new project. AlgoKit init, so if I do AlgoKit space init, is the command we want to run. And if you're like a Web 2 developer, this is very similar to like create React app or something like that, where it gives you a project with recommended like plugins, recommended dependencies. But of course, you as a developer can go in and change things after the fact. This is just the default template that we recommend that you start with to make your life a little bit easier. So when I do an AlgoKit init, it's going to bring me to what we call the init wizard. And this is basically a series of questions that helps set you up with the project that you actually want to build. So you can see here, the first question it asks me is what I'm building. I can either choose a smart contract, a dApp front end, or I can do both. Now, to start, I'm just going to start with the smart contract. So I'm going to go ahead and select that. And now you can see here, we have the option to build in Python, TypeScript, or this old language called PyTeal. If you're new to Algorand, just pretend PyTeal doesn't exist. It's honestly a pretty crappy experience. So we now have Python and TypeScript. So I'm going to go ahead and choose TypeScript. And again, as Chris mentioned, both Python and TypeScript are just native Python and TypeScript syntax. If you're coming from Solidity, because Solidity is ECMAScript based, you'll probably feel a little bit more comfortable with TypeScript. But ultimately, choosing Python or TypeScript is just about which language are you more comfortable in. They both can do the same things, they have the same features, and provide a really compelling developer experience for those even new to Algorand. But for this, because we're at ETH Denver, and I assume some of the developers here are familiar with Solidity and TypeScript, I'm going to go ahead and choose that. And I'm just going to make up a name of project. I'll call it Hacker Mansion. And what this is going to do is it's going to start to initialize that project directory. And I might have cursed myself here saying about internet going out. It seems like it seems to be hanging. So what this is doing is basically it's going to a template on GitHub and then initializing that template based on the options we give it. So it doesn't seem to be loading right now, so I'm just going to go ahead and show you what the complete project looks like. So if we go over to what a project actually looks like, so here, how I got this directory structure is I ran AlgoKit init, and I gave the name NFT membership app, and here it created this directory. And now this is the directory structure that everyone that uses AlgoKit init, whether they choose smart contracts, whether they choose a front end, or they're using their completely own custom template, this is the layout that they are going to be using. And so in the top level directory, we just have some stuff that's common to every Git repository. We have like a dev container, so you can use a code space or Docker. We have our git ignore file, and then our special AlgoKit.toml file. This AlgoKit toml file tells AlgoKit, the command line tool, a little bit about our workspace. And in the future, we're also going to be using this file to define like orchestration commands. So, for example, in your package JSON, you have scripts, or in your poetry .toml, I think it is, you have scripts, and eventually you'll be able to basically combine both of those in your AlgoKit toml. So this is the equivalent of like a package JSON for an Algorand project. But if we go down into this projects directory, this is where our actual code lives. So in this example, this is going to be an NFT membership app. So it's going to be a smart contract where you give it some amount of algo, and it'll give you back an NFT saying that you're a member in that smart contract. So we have our smart contract for actually doing that membership and the token minting and that sort of stuff. And then we have a front end to make it easy to interact with. So what AlgoKit does is for each different component of our dApp that we're building, we have a separate directory under our projects. So here, because this is a truly decentralized dApp, we don't have a back end, right? We just have our front end running in React that runs in browser. But if we were to have a back end, like a Django back end or an Express back end, that would just be another directory here under projects. So what I'm going to do is I'm going to start with the smart contract and then talk about how we actually integrate that into a front end. So in the smart contract template, you can see here that the folder is named TypeScript, and this looks exactly like a, let me see if I can make this bigger a little bit. I guess not. So this looks exactly like a regular like TypeScript project, right? We have our test directory, we have an ESLint configuration, we have a prettier toml file, we have a just configuration, our package JSON, and our tsconfig. So because we're using native TypeScript to write our contracts, we're using the same tools that you know and use for writing any other TypeScript project. So this should be a fairly familiar layout. And then our actual code here, in Algorand, it's common practice to put your code under a contracts directory. Like for example, when you're building with TypeScript or React, you have a source directory. In Algorand, our standard is you typically put it under contracts, but your contract can go wherever you like it. And this is where our actual contract lives. So in the contracts directory, you could have a bunch of TypeScript files, and you can see here we have NFT membership app.algo.ts. Now, again, because it's native TypeScript, we have the .ts extension, and we also have that .algo like sub-extension. That .algo isn't necessary, but it's, again, common practice to use because it helps us differentiate our Algorand smart contracts and the rest of our TypeScript code in our project. For example, so we can tell ESLint to have different rules in our contracts and in our like front-end code if we wanted to. But popping open this file here, basically what I'm going to do, like I said, this is already written, so I'm going to go through the code. I'm going to quickly show you just like the overall layout of the code, just so you can get an idea of what it looks like, and then we'll kind of break down about what it's actually doing. But taking a look at the high level, this should look pretty familiar to you if you're already a TypeScript developer. We're going to start off by importing our dependencies. Right now, we are just importing TypeScript, our contract class, because we're going to be writing a smart contract. And TypeScript also supports importing other contracts. So if you're a Solidity developer, you've probably used like something like OpenZeppelin that gives you a bunch of like templates and pre-created contracts that you can inherit from. So we don't yet have an OpenZeppelin on Algorand, but that is totally possible with our tools for both Python and TypeScript. And I should also mention that we are writing native TypeScript syntax, but we can't use TypeScript libraries. So I can't import a library that was designed to run in like a node environment in my contract, for example. So I'm only importing things from TypeScript or other contracts that I've written with TypeScript. Now going down into my contract, I define a contract by instantiating or by defining a class, much like you do a regular TypeScript class. In this case, we're calling it NFT membership. And then we're going to extend contract. And extending contract does a couple things. A, it tells our compiler that this is our smart contract class. And B, it gives us access to contract-specific functions that don't exist in regular TypeScript classes. Now, again, I'm going to quickly go over just kind of the layout, and then we'll go back up and kind of drill down into the details and what's happening here. But you can see it's laid out just like a regular JavaScript class, right? We have our properties here with our tsdoc comments. We have private functions that we use internally within our contract. And then we have public methods that can be externally called by either other contracts or anyone on-chain, like through our SDKs. So overall, the layout of writing a contract on Algorand is very similar to writing a actual TypeScript class. So let's talk a little bit more about what we're actually doing here in this NFT membership app contract. So like I said, what we basically want to happen is we want to create a contract that can take algo and then give back an NFT if the person pays enough. So we basically just want this to be like an exclusive membership contract. This is kind of like the building block if you wanted to like create a DAO, for example, and you want a DAO membership to be represented by NFTs. This would be kind of how you get started with that. Now, of course, this isn't the only way we could do that, but this is the implementation we're going to be going over today because it touches on a lot of the core concepts that are important to know as an Algorand developer. So getting started, the first thing we typically like to do when we write a contract is we think about what sort of stuff we need to save on the chain. So as Chris mentioned, we have various different types of storage on Algorand. And here we're using two types of storage. We're using our global storage and our box storage. Now, our global storage, it works pretty similar to just like a regular TypeScript property. So these two, membership price and membership NFT, are what we're saving in global storage. So these are basically properties in our contract that we want to persist between every call. And the names are pretty self-descriptive. So our membership price, it's going to hold a number that tells us how much someone has to pay in order to be a member of our contract, thus get the NFT. And then we have our membership NFT, and this is saving what we call an asset ID. As Chris mentioned, we don't have, or we have assets baked into the protocol. So assets aren't a contract, and they're uniquely identified by a unique integer that every asset is assigned once it's minted. So once we create our membership NFT, we want the contract to save that ID so it knows what NFT it should be giving people when they actually register. And one other important thing to note is that for our membership price, we're saving it in an unsigned 64-bit integer. This is one of the differences between Ethereum and Algorand. In Ethereum, the EVM natively works with 256-bit words, and Algorand, the default or the standard integer that it works with is an unsigned 64-bit integer. As Chris mentioned, you can work with up to uint 512, but working with uint 64 is the most optimized integer type that you can work with, and it's the default integer type that is used in like transaction fields. So for example, if I'm transferring someone some algo, the amount that I'm transferring is always specified in a uint 64. So that's why we're using that type here. Now, so that's our global state, and that's just going to be saved in the contract. So every time someone calls it, they're going to have access to this global state, and the contract will be able to remember this. Now, our other type of storage is our boxes. And boxes, how we're using it here is very similar to how a mapping works in Solidity. What we basically want to do is we want to have this property called member info, and we want that to hold a map of an address to a Boolean. And in our case, this is just going to be a Boolean indicating whether this address is actually a member or not. So we're just going to have a simple one-to-one. When someone calls a contract, that their address is going to be the key, and then a Boolean is going to be the value. And we'll see how we actually use these as we get into our logic. But starting off, the first thing to note here is that we have the ability to define private methods. So just like in Solidity, we can have private and public methods. And here, we can do the same. By default, if it works just like TypeScript. If we don't define a specific keyword, it's going to be public. But because we said private here, this is going to be a private method that is only callable internally within the contract. And what this method is going to do, it's going to do an assertion. So this is very similar to Ethereum, where you can assert whether something is true or not, or whether it's non-zero or not. So here, I just have a method called authorizeCreator, and it's just going to make sure that the sender, so the person calling this app, is the same as the person that created this app. And this is basically similar to like the Open Zeppelin ownable, where we're saying, basically giving access control and saying, whenever we call this function, it can only be callable by the person that created the contract. And if that isn't true and our assert fails, then our smart contract call would fail and we aren't charged any algo, and we have to either call a different method or get the creator to call it. Coming down into our first lifecycle method. So on Algorand, one of the unique things about smart contracts is that we can not only, of course, create them, but we can also update and delete them. By default, Algorand smart contracts are mutable, but if you're writing with TypeScript or Python, they will be immutable by default. So the only lifecycle method we're defining here is our create. And so what this method is going to do, it's going to define the logic that the contract will execute when we first instantiate it. So here, because we're creating our membership contract, we just want to be able to pass in our price and then save that in global state. So that's all we're doing here in our creation. So when we first create the contract, we execute this logic, and that saves our desired price. And this is going to be the price of the NFT. Now, after we've created our contract, we can call our other public methods. Our first one is going to be create membership NFT, and this is going to be a method that allows us to mint that token. And so as our arguments, we're going to be passing information about that token. And because tokens are a native feature of the Algorand blockchain, we don't need to create another contract. We just send a transaction called an asset create transaction, and we can pass in all the information that we want here. So you can see, in order to mint a token, I don't need to define any extra logic. I just call this one function, send asset creation, and that natively creates an asset that'll have our name, the total that we wanted to create. We can specify how divisible it is through our decimals, our unit name, our asset URL, which will contain like our IPFS metadata. And then we also have all these other like role-based access control methods. And now Algorand, because we have assets natively supported in the blockchain, we want to give developers flexibility in how those assets behave. If we didn't have additional functionalities in our core ASAs, then developers would want to just make their own smart contracts anyways. So we have a couple of common features baked into our tokens that you commonly see in smart contracts. Now, all of these features that I'm going to mention are completely optional. So if you're minting a token, you don't need to enable these, but they're there in case you want to. So the first of which is clawback. And this is basically specifying if an address has the ability to claw back a token from any other address. So in our case, we're saying the clawback address is going to be the address of our app. So this is basically saying this contract can take the token out of anyone's address. And again, this is a completely optional method, and we'll talk about how we're going to be using this a bit later. But then we can also define another functionality of Algorand is being able to freeze assets. And both this and clawback are very useful for like regulated assets. So for example, USDC, they will not deploy their token to a network if there is no way to freeze assets. So having this native functionality is very important when you consider specific regulatory concerns for different implementations. So freeze, as the name suggests, allows a specific address to freeze the assets in another person's account. And then we also have our manager address, which can update these fields. And then our reserve, and this is just going to be the address that holds the unminted tokens. So what we did is we called send asset create to create it. And then we just saved this value in our global state. So again, our membership NFT is the asset ID in our global state. and we're just going to save it by calling dot value equals our created asset. So that's all it takes to mint a token on chain. It's just one single send asset creation transaction. So now that we've minted our token, we have this get membership function, and this is what users are going to interact with when they actually want to get that token, when they want to sign up for membership in our app. Now, the arguments here are a bit different than the arguments that we've had before. The arguments we had before behave just like you would expect them to. I pass a number, I can then use that number in my function. But these arguments are a little bit different in that these arguments are actually transactions. So on Algorand, one of the native features is atomic transactions. And when we have a transaction as an argument to a contract call, what we're saying is that these transactions must happen atomically. So I have this get membership function in my contract. I have this pay transaction as an argument, and I have this asset transfer as an argument. So this means whenever someone calls get membership, it must be grouped atomically with a pay and an asset transfer. And by doing this, I can now introspect these transactions and make sure they are what I expect. So if I look in here, we're just doing a couple of asserts to make sure our state is what we expect it to and that this person isn't already registered. And then we verify the fields in these transactions. So I specified, for example, I have a payment, and this is going to be an algo transfer. And now I want to look at that payment and make sure that the payment is the amount of the membership price, it's being sent to this address, so the contract, and it's being sent by the sender. So what I'm doing is I'm making sure that when I call this contract method, I'm always paying the contract account, however much my membership price is. Yeah.
Like in the first assert, what case would you have this assert fail? So if this membership NFT not exist, does it mean that the contract is not been sent yet?
Yeah, so this would be not true when we haven't yet called our create membership NFT. So when we instantiate the contract itself, we call create application. And then once it's deployed, we need to call create membership NFT to actually mint that NFT. So if someone tries to get the membership before that NFT is minted, then that assert will fail. So we're verifying the atomic payment to make sure that we pay the contract the amount that we want it to. And then we verify our asset transfer. And this asset transfer is what we call an opt-in transaction. And this is basically a way to tell the ledger on Algorand that this user wants to receive this asset. By default, you can't send any asset to any address. That address has to specifically say, I want to receive this before anyone can send them. And this is helpful for spam and also helpful to make sure that people are paying for the assets in their account that is taking up space on the ledger. So an opt-in is basically a transfer from one account to itself of amount 0. So once I do this transfer from myself to myself of amount 0, I'm telling the network, hey, I want to be able to receive this asset. And now, in this case, we're making sure that our transaction sender, the person calling get membership, is opted in. Once we verify that they are opted in, we can go ahead and send the asset to them. And again, we're not calling a contract, we're just calling send asset transfer, and this will execute an inner transaction that sends that asset from the contract account to the caller. Once we've done that, we're just going to go ahead and update our member info and set that value to true to signify that this person has indeed registered. And now, if they try to call it again, this will fail because we are asserting that this membership value is either false or doesn't exist yet. Now, finally, we have our cancel membership. And what we're going to do here is basically inverse what we just did in our get membership. So we're going to make sure that the person calling this is indeed a member. And then what we're going to do is we're going to have the contract take back that asset. So when we created our asset, we specified a clawback address, and that was this contract itself. And that means this contract can take that asset back from the user without them having to sign anything or do anything, without their control. So what we're doing is we're going to send an asset transfer. And what we're saying is we're going to be sending it from this contract account, and we're going to be transferring the membership NFT to NFT, so we're just transferring one. But the important thing here is that we're saying the asset sender, so the account that the asset is coming from, is our caller. So whoever calls our cancel membership function, they're going to lose their token. And we're transferring it back to this address. So if someone else registers, we can send that same token to them. Now, once we do that, we're just going to do some cleanup. We're going to delete our box. So delete that key value pair in our storage. And then we're going to refund them the amount of that it cost to register as a member. So the whole life cycle of this app is first someone calls the create application, and then they create the membership NFT, and then anyone can come in and either get membership or cancel the membership if they've already done that. So that's what the smart contract looks like. Now to quickly kind of go over what integration looks like in our front end, if we take a look in our contracts directory, so here in our projects, still in our TypeScript, under contracts, we have our artifacts. And these are the files that are generated when we compile this TypeScript code. Now, if you're an EVM developer, you're probably familiar with the ABI. On Algorand, we use a very similar ABI. It's not 100% the same, but a very similar ABI and ABI JSON specification where we describe the contract and basically all the things that it can do. We describe all the methods, that sort of stuff. And then we also generate our TL. So this is the low-level language that the AVM actually understands. But we don't actually want to deal with that stuff directly. We want to make our lives a little bit easier. So another artifact that we generate when we compile our contract is this auto-generated client. So whenever we build a TypeScript or a Puya contract, what we can do is we can take that ABI information and use it to generate a type-safe client. So here, it's about, I think, almost 500 lines of code, or even more, almost 1,000 lines of code that AlgoKit generated for us. And what this allows us to do is interact with our contract in our front end in a type-safe manner without having to write this basically like a broker between our front end and our contract. It does it all for us. So to see how that's actually used, I'm going to come over to now let me close this. I'm going to come over to my front end directory here. So close out of TypeScript, go to front end, and I can see in my components, I have various components here to interact with my app. And these all these components, what they're doing is they're taking in that typed client. So when I build it in TypeScript, I generate that typed client, and then to actually interact with the app, I use that generated client to interact with it. So I can see here in this React component, I'm passing in that auto-generated typed client, and I'm using that to call a function. In this example, I want to be able to call the on-chain cancel membership function, and I do that by calling typed client dot cancel membership. So now without having to worry about how like the ABI signature and what the contract ID is and all this extra information I need to know about the contract, I simply just use this auto-generated client to simply call typed client dot the name of my method. Now, before I go into more details, what I can do, so I can show you, it's this way, I can show you what this front end actually looks like. And then we can go into a little bit, show you a little bit more about the directory structure, and then we can have some Q&A. So, yeah.
Just a quick question.
Yeah.
Those types that were defined on the smart contract, like asset ID and asset
Mm-hmm.
transaction, are those coming from AlgoKit or do you define those yourself?
So those type, like in the contract, those are types defined in TypeScript, but they map to types that are also defined in AlgoKit. So in our front end, it's not like the same type, but there's a like one-to-one mapping of types in your contract, you have the equivalent type in your front end through AlgoKit. Yeah, so I should disclaim that I am not a front end developer, so this is a pretty simple and ugly and probably poorly written front end. But it kind of demonstrates the power of AlgoKit for someone like me. You can still write a somewhat decent front end pretty easily. So here what I can do is I can define a membership price. And because app ID is 0, that means I'm going to create it. I'm going to go ahead and create my membership. Actually, before I do that. Nope. Let me first make sure I'm actually running it. So by default, the AlgoKit template comes with like a wallet connector library. And because I'm just on my local net, like I'm not connected to mainnet or testnet, the only option here for a wallet is our local net wallet. But if you were to switch to testnet or mainnet, which is done just like in an env file, then it would display all the different wallets that support Algorand as well. So as a developer, you don't have to worry about wallet integration. That's done for you by the AlgoKit template. But I'm just going to connect to my local wallet here. You can see I've connected this GB6 account. And now I can come here, say I want to create a membership contract that costs 2 algo. I'm going to go ahead and mint that. And what that did is it created my contract. So on Algorand, every contract has a unique ID. On my local network, this is contract 1438. And it also created a membership ID. So if I take a look at what that looks like on the Explorer, you can see here I've created a membership NFT. Now this is just a random NFT that I own that I copied the image from, but the idea is that we were able to, on-chain, in our contract, when we first created it, we were able to mint an NFT, and we can now see that on the Explorer without having to mint other contracts. Like this is all just natively supported by the chain itself. So now that we've created our app and we see that we have a membership NFT, if I go ahead and click register, and I come back to my Explorer, no, I think, oh, I have the wrong Docker service running, my bad. Let me see, I can quickly fix that. Sorry about this. Should have checked that my local network was up before I started here. So this will be a good time to show how easy it is to start a local network. So to start a local network, I can just do an AlgoKit localnet start. Now it's going to go ahead and use Docker to automatically create my network. And now that I have the proper network running, I'm going to have to log out and do this again. Connect to my wallet. Say a membership price is going to be 2. Oops, not -1. 2, create. We just created a new network, so it's now asset ID or app ID 1001. And I connect to my local network here. I can now see that I've minted that on chain. And if I come back, and I open that in a new tab, and I register, we can now see on chain that we've sent that transaction from the application to our person that wants to register. And if we go ahead and cancel, and we refresh, we now see a new transfer that sends it from, that was the clawback, sending from the user to the application. So in our front end, we're able to leverage this typed client to very easily do all that sort of on-chain interaction with just a single function call in this instance. And what's also really useful is that these components, they're actually pre-generated by AlgoKit as well. So when we generate our TypeScript contract, one of the things that's generated is all these auto-generated React components. Now, of course, we're going to have to make some changes because it can't know everything about our contract, but we can use these pre-generated React components as like a starting point for our integration. So the whole idea here is that we start with our TypeScript contract, which is just native TypeScript, and then we can automatically generate front-end code to make the front-end integration for our AlgoKit contract as seamless as possible. And that is eventually what allows us to create this front-end using the AlgoKit template. So again, that is kind of the high-level overview. Like I said, the kind of the vibe of what it's like to build on Algorand. If there are any questions, I'm happy to answer them now, or we can, or you can come up to me later. Yes, question. Yeah. Say that again. Oh yeah, yeah, yeah.
ID finding for new dApps. Can you expand on that a little bit? And
Yeah.
and on the clawback, the call for the clawback, I think is very interesting, very innovative, right?
Mm.
And how long do you have for doing that call, or you is there's no time, you can do it whenever you want?
Right. Yeah. So for the clawback, if the clawback is enabled in the asset, then it can happen at any time. But again, it's like a completely optional feature. So for any given asset, you just have to check if clawback is enabled, and if so, then you know that address can revoke it at any time. Now, if you as a developer wanted to implement like a timeout for the clawback, for example, you could create a contract, and that contract does the clawback, and in that contract logic, there's some like time component. So the native feature doesn't have like a time aspect. It's just like a Boolean, either it's enabled or it's not. But you can use smart contracts to add some more flexibility to that feature. And then for the asset ID, so basically how it works is, let me pull up the contract again. Script contracts.
So it's
So
like an 1155 on assets using Algorand.
yeah, so basically how it works is that um, when we create the asset, we have a unique address, so or a unique ID. So every time an asset is created, it has a unique ID that is returned in that transaction. And so this could be the asset that we create could be like an 1155. It could be it's more like an ERC20. It could be whatever kind of underlying primitive asset that we want it to be. But every asset that we create always has a unique ID. And so the important thing, if it is like a fungible token, for example, like Algorand has USDC. USDC, there's one unique ID for USDC, but it's a fungible token. So there's millions of different accounts that hold USDC, and it's always that same asset ID. So whenever we create our token, the network assigns it a unique ID, and that ID is just based on it's based on like the transaction counter. So it's guaranteed to be unique for every asset, and it's the same for apps. So every asset and every app, it looks at the transaction counter, and that's the unique ID for that. And then every time we want to like transfer that asset or configure that asset or delete that asset, that's the asset ID that we use to interact with the network. Does that answer your question?
Cool, cool. Thank you. Yes.
All right, cool. Yeah.
Is there a way to test these contracts before deploying them to the network?
Yeah.
Sure, I
Yeah. Yeah. Just
My question was, is there a way to test these contracts before deploying them to a network?
Yeah, so that is a great question. We actually do have tests, but I didn't go over it. So in this case, so first off, because we're using our AlgoKit LocalNet, this is it makes our lives easier because we don't have to worry about like dispensers or like using real money, of course. But also the block time on our LocalNet by default is like instant, and so this is really useful for like testing a contract. So here, what I've done is I've written test using our contract using Jest. Now, of course, you can use whatever framework you want to test, and we're using, much like in the front end how we had that auto-generated client, we're using the same exact client here in our Jest test as well. And so here we have a bunch of different test cases for all the different methods here in our contract, and each of those they're using that type client that we auto-generated. And if we want to run them, you go to CD projects TypeScript. I do an npm run test. It's going to use Just, and because we're on a local net first it's going to build it, and then it's going to run our test. And because we're on a local network, it just sent like a bunch of transactions super quick. So the the iteration workflow with testing is pretty quick. So generally, what we recommend is like the general life cycle is you build your contract, you write some tests against local network, as you iterate, and then once you're ready, we have a test net, like much like test net on other blockchains, where it's the exact same, like the exact same software version as mainnet, just a different ledger, and then you can use that to like test with end users, and then eventually once you're ready, you can go to mainnet. So that's what the general life cycle looks like. Yeah.
Is there a mock environment to test for, or only on local?
So there is, you can test on, we have a public test net. So you can test on a test net, and we do have, like part of AlgoKit, we have a dispenser built in. But because the local net is like instant block times, you don't have to worry about like dispensing. We generally recommend using that at least at first to start testing. Yeah. Sorry, can we just wait for the mic?
Thank you, Ron. One. My question is, have you played with using ChatGPT to generate code? And if you had, what is your experience and what are your thoughts on it?
Yeah, so it's actually this is one of the really nice benefits of using like established languages like TypeScript and Python, is that these large language models like ChatGPT are already familiar with it. So I have used ChatGPT. In fact, I actually used it a lot. So if you go to the TypeScript repository, there's like a bunch of examples, and a lot of those were actually written. A lot of the code was written by ChatGPT and GitHub Copilot, because at the end of the day, it's just native TypeScript. ChatGPT kind of knows like how to read it and how to write it. Now, of course, there is some like Algorand specific stuff that it doesn't know, but it is still extremely useful to use, especially compared to like proprietary languages like PyTeal we had in the past.
So, what would it take for ChatGPT to know the Algorand specific stuff?
Yeah, so for that, you would probably want to like fine tune the model. So you'd probably want to give ChatGPT like our Algorand docs, and like this would be easier if like you were using like the API to do it programmatically, or you like we're using a different model and fine tuning that. We actually have like on our Discord server, we have an AI bot called Kappa, and it's an AI bot that's trained on, I think, all of our developer docs, our repos, and some other resources. And so that bot is really good at like knowing Algorand questions, but it doesn't write a ton of code. So conceivably, we could kind of like combine the two functionalities where you have something that's fine-tuned for Algorand, but also has the general programming knowledge of like TypeScript, and get that experience. But we don't. That's not something we have right now.
Thank you so much.
Yeah.
Great. Do we have more questions, guys?
I have two more questions. if you guys have to go with another.
Can we have one
Yeah,
more?
yeah, I mean,
let's go.
yeah.
No validators. If you guys need validators, I would love to talk to you about validators.
Yeah, so just like validators in the network.
Yeah.
Um,
Providing that for you guys.
yeah, so right now anyone can set up a node and start validating. There's no like minimum barrier for entry, and it's relatively low, like CPU cost. So the only thing you need is you just need some stake and you just need to own some algo, and then you can spin up a node.
How much is the staking?
It's just zero 0.1 algo. There is no, which is like the minimum for the ledger. So there is no minimum amount.
Cool. And the other question was if you think that is something that Algorand can support or grant to build the library for all these awesome features that you guys have very specifically on smart contracts, sort of similar to Open Zeppelin. If this is something that maybe we can even do it with the blockchain lab and support in the work that you guys doing and build like a library and get support or some grant or something, and we can build like a library of all the smart
Mm.
contracts similar to OpenSea. Is this something, because there's none, I don't know how big could be, but I think it will be a cool project for you guys.
Yeah, yeah, definitely. I mean, the fact that we can now inheritance with like TypeScript and Python are relatively new features. So like you said, we don't yet have Open Zeppelin. Right now, we don't. The foundation doesn't have a like direct grant program. We have a decentralized grant program called Xcoves, so you can receive funding through that. I'm happy to talk to you a little bit more. After the workshop, and we can talk about what you had in mind and figure out the best way to go forward with that. But in general, yeah, that is something that we ideally want for both TypeScript and Python, because I think that's a really compelling part of the Ethereum ecosystem is being able to leverage Open Zeppelin. So it'd be great to have that in Algorand.
Okay, so that was a code demo. Hopefully that demo kind of showed you how easy it is to get started on Algorand. But I know a lot of you guys love learning by coding. So we prepared this fun coding challenge for you guys. So the app that Joe showed was a simple one where there's only one tier of membership. But this coding challenge is for you to implement a multi-tier membership feature. So the smart contract should be able to create 3 tiers of membership, and based on how much algos users send to the smart contract, it should know what tier of membership entity to give out to the user. So we're giving you guys 2 weeks to do this. So due date is at March 8th, so a week, giving you an extra week after December because I know you guys are super busy partying and meeting people. Yeah, we created a dedicated Discord channel inside of our Algorand server. So if you find Ethember, Hacker Mansion, and ask your question there, Joe and I will be there, and also our other DevRels to answer your questions so that you can finish this challenge. We're also going to be giving out verifiable certificates for completing this, and it's this beautiful certificate that we created. But this is just yes, great. This is just not an image. This is also using the Go Plausible platform to create a verifiable credential. It follows the global standard for certificates and also includes a DID that follows the W3C standard. So this is actually a valid certificate that you can show, add it to your LinkedIn, and share to the world that you know how to build an Algorand. All right, I'm going to share you guys a couple of developer resources that you can leverage. Yeah. Yeah, it's at the end. It's at the end. Yep, there's a QR code that has everything. So I'll get there. Some developer resources that you can leverage. We have the YouTube channel. We post tutorials, courses, concept overviews. So this should be definitely the first step you go to. This you really can use for the coding challenge, but we have regular boot camps. So if you really want to dive deeper into Algorand, there's one coming up in mid-March, right? So mid-March, so you can sign up for that and have a live session where you can ask questions, have coding sessions, and all of that good stuff. We have the developer documentation where you can find everything about Algorand, but it's often hard to find information that you want. So like Joe said, we have a ChatGPT-like AI tool where you can ask your question, and it will get you that answer. This is the Discord channel that we have. You can go here and ask your questions while you're building on Algorand. The DevRel team and our vibrant Algorand developer community are on there, always providing technical support. Now, if you like to just learn by looking at sample code, we have a separate developer relations at Algorand GitHub repo where we have a lot of sample applications, so you can just dive straight into the source code and learn from that. But this is the QR code that I promised you. This has the GitHub repo for the coding challenge, the invite link to our Discord server, the developer resources, everything, our socials. We would love it if you connect with us on our socials, share your experience from this event, what you think, what you didn't like. Just would love to connect there. So take this moment to scan this QR code. And if you're going to participate in the coding challenge, the Discord, if you go into the Discord server and find this ethamber-hacker-mention, and that's a dedicated channel we've created for you guys to ask your questions. But on that note, that's everything that we've prepared for this presentation. I really hope that this presentation has taught you everything that you were curious about Algorand, what it's like. But this presentation wasn't really to tell you guys, oh, Algorand is great, come over, build here. But to really get that message across that we've made the developer experience as easy as possible. We dedicated the entire year of 2023 to improve our developer experience to the top of the industry, so that when you come over to Algorand, you're not frustrated setting up your development environment or dealing with unnecessary stuff that all developers hate. We want you to have a pleasant experience building smart contracts, delivering your product. So I really hope that this presentation has inspired all you to take a deeper dive into Algorand, see what's happening here, the ecosystem, what the technology enables you to build, and bring your ideas and build an application that's going to shock the world. Thank you.